the probability that Robert is late to school is 0.7. Calculate the probability that Robert is late to school for each of the next 2 days. So day 1, the probability of Robert being late on day 1 would be 0.7. And the probability of him being late on day 2 is also 0.7. And the probability of him being late for 2 days is 0.7 times 0.7 equals 0.49. Next, Janet spins a 6-sided spinner numbered 1 to 6. The probability of it landing on each number is shown in the table here. Find the value of x here. So if you add up all the probability, you will get a total of 1. To find x, take 1 and subtract all the other numbers. So x equal to 1 minus 0.21 minus 0.07 minus 0.15 minus 0.22 and minus 0.21 equal 0.14. X is 0.14. Next, Janet spins the spinner twice. Find the probability that it lands on the number 4 both times. So the probability of the spinner landing on number 4 is 0.15. So if it lands on number 4 both times, the probability would be 0.15 times 0.15 equal 0.0225. Next, find the probability that the sum of the two numbers is 10. Sum of the two numbers is 10. So how do we make 10? 5 plus 5 and 4 plus 6 makes 10. So the first combination would be 5 plus 5, right? The second combination is 4 plus 6. Or you can also spin 6 first and then you get a 4. So all these are ways to make 10. Let's count the probability. The probability of it getting 5 twice is, okay, this is it, 0.22 times 0.22. Okay? What about 4 plus 6? So you get 4 the first round, that's 0.15, and then you spin it one more time and you get 6. Okay? And that is 0.21. Okay? What about spinning 6 first and then getting 4? That is 0.21 times 0.15. Okay, let's look at the probability. This is 0.0484. This is 0.0315. This is also 0.0315. So the probability that the sum of the two numbers is 10, add these three up. You'll get 0.1114. Okay, are you following? Let's look at the next question. The probability that a biased dice lands on the number 6 is 1 over 4. The dice is rolled 2 times. Complete the tree diagram. Okay, first throw, second throw. Now the probability of the dice landing on 6 is 1 over 4. If it's not a 6, so 3 over 4, right? Just subtract this. 1 over 4, not a 6, 3 over 4. Okay, same. If it's a 6, the probability is 1 over 4. If it's not a 6, it's 3 over 4. Find the probability of throwing at least 1 6. So you're going to throw the dice twice, but you need your result to have at least 1 6. First throw, you get 6, and in the second row you get 6. This fits the criteria, okay? First row getting 6 and second row not getting a 6 also fits the criteria of throwing at least 1 6. If your first row is not a 6, you need to get a 6 in the second row. Okay, so this is not in the criteria. You have 3 possible outcomes. First outcome is getting 6 in each throw. So 1/4 times 1/4, right? You're getting 6 at each throw. The second outcome that fits the criteria is getting 6 in the first throw, but not getting a 6 in the second throw. So 1/4 times 3/4. The third possible outcome is getting a 6 in your second throw. Okay, so you didn't get a 6 in the first throw, but you get a 6 in the second throw. Let's multiply. This is 1/16. This is 3/16. This is 3/16. Add them all up. You get 7/16. Next, now the dice is rolled 3 times. Find the probability of throwing exactly 2 6s. So what you can do is extend this tree diagram. Third row, okay? 1/4, that's a 6, and maybe you don't get a 6. 3/4, not a 6, right? Here too, you get 2 possible outcomes. Here, 2 possible outcomes. And here also 2 possible outcomes. You either get a 6 or you don't get a 6. Now let's find the probability of throwing exactly 2 6s. You're going to throw the dice 3 times, but you only want 2 6s. So what's the outcome? First throw you get a 6. Second throw you get a 6. Third throw not a 6, right? Because you only want to get 6 twice. This is the first possible outcome. Or you get a 6 in your first row, you don't get a 6 in the second row, and you get a 6 in the third row. This is your second possible outcome. Are you following? Okay, another possible outcome is not to get a 6 in the first row, and then you get 6 in the second and third row. Okay, this is one possible outcome that fits the criteria. Or, okay, wait, and that's it. Let's calculate. Take 1/4 times 1/4 times 3/4. Okay, this is your first possible outcome. Plus, the second possible outcome is 1/4 times 3/4 times 1/4. And the third possible outcome is 3/4 times 1/4 times 1/4. So use your calculator. You should get 9/64. 33. A bag contains 5 red sweets and 4 yellow sweets. I'm just going to jot it down. 5 red, 4 yellow. Ali chooses a sweet at random from the bag and eats it. That means after taking one candy out, one sweet out, he's not going to put it back inside the bag. He then chooses a second sweet at random. Find the probability that he chooses 2 different colored sweets. Okay, so let's look at the total number of sweets that we have. We have 5 red and 4 yellow, which brings to a total of 9 sweets, right? If he chooses a red sweet in the first try, the probability of getting a red sweet is 5/9 because it's 5 red sweets over 9 sweets in total. Okay? And they want 2 different color. So if the first try is red sweet, his second selection should be yellow sweet. It's 4 over, this time your total is 8 because he has eaten 1 sweet, right? Which is the red sweet. So 5/9, times 4 over 8. The other possible outcome is to draw a yellow sweet first. So that's 4 over 9. See? 4 yellow sweet out of 9 sweets. And getting a red sweet in the second try. That's 5 red sweets over 8 sweets. Okay? And the answer is 5 over 9. That's the probability of choosing 2 different colored sweets. The circular board is divided into 6 numbered sections. When the arrow is spun, it is equally likely to stop in any of the 6 sections. The spinner is spun several times until it lands on the number 2. Find the probability that this happens on the 5th spin. So you're going to keep spinning the arrow until you land on number 2. So how many 2s do you see on this board? 2. So the probability of landing on number 2 is 2 out of 6 because there are 6 sections. And the probability of landing on a number that is not 2 would be 4 out of 6, right? Because there are 4 numbers that's not number 2. So what is the probability of landing on number 2 on the 5th spin? So just make sure that you have 5 sections because you're going to spin it 5 times, right? See? 1, 2, 3, 4, 5. So you need to land on the number 2 on the 5th try. So this is 2 over 6. And all the other spins would be not number 2. 4 over 6. 4 over 6. 4 over 6, right? It's this probability. 4 over 6. So compute this onto your calculator. 16 over 243. A bag contains 5 red balls, and 3 green balls. Jane selects balls at random from the bag without replacement. So your total 8 balls will get reduced one by one until a green ball is selected. Find the probability that this happens on the 4th selection. So this is quite similar with the previous question. You need to get green at the 4th try. So first try times second try, third try, and 4th try needs to be a green ball. Therefore, the first 3 tries would be red ball. Okay, the probability of getting a red ball in the first try is 5, because 5 red balls out of 8 balls. 5 over 8. The probability of getting a red ball in the second try would be 4, because you've taken out 1 red ball. There's only 4 red balls left over 7, total of 7 balls, because you did not put the ball back. And the probability of getting a red ball in the third try would be 3 over 6, because 3 red balls left and 6 balls in total. And now in the 4th selection, green balls. So 3 green balls, 3 over 5, because you only have 5 balls left in the bag. And the probability of getting a green ball in the 4th selection is 3 over 28.